Assalamualaikum and hi to everyone. My name is Nur Aina in the Empower Zone. I will present about structure analysis of real frame building system in mechanic of material, and we are from group 6 section 4. Next, I will introduce our group member. The first one is Khairunisa Naziha. Number metric is CF240157. Me, Nur Aina in the Empower Zone, CF240121. Nargis Najwa, TF240168. Alia Khadija, TF240166, and last one is Nurul Iza, the F240165. Next slide, I will continue with the introduction of this project. Shear force, often simply called shear, is the internal force that acts parallel to the cross-section of a structural element. It represents the tendency of one part of the structure to slide past an adjacent part due to applied loads. In beams, shear force are highest near the support where the load are transferred downward. If shear force are not adequately resisted, they can cause cracking or sudden brittle failure, especially in material like concrete. Bending moment is the internal force that can cause structural elements such as beam or slab to bend under a load. When a load is applied perpendicular to a beam, it creates a tendency for the beam to bend or flex. The bending moment at any point along the beam is the sum of the moment, force time distance, on one side of that point. So the next slide, we talk about background of study. In reinforced concrete structure, beam and slab primarily carry bending moment, which cause them to flex and bend under vertical load like the weight of floor or occupant. At the same time, column and connection are vital for transferring shear force and axial load down to the building foundation safely. In this project, the analysis is carried out both analytically and computationally to ensure the structural performance align with safety standard and design code. The project includes selecting real structural components from actual building, such as beam, wisdom in, arcade, foot court, F-cup porch, and calculating their internal reaction, shear force, bending moment, stresses, and deflection. Overall, the background set the stage for understanding the behavior of frame building system under realistic loading, which is crucial for safe, functional, and efficient civil engineering design. So I will move to the next slide with the next presenter.
So for problem statement, structure element in real-world condition are exposed to various types of load, such as dead load and live load. Without proper analysis, this element may fail to meet safety and serviceability standard, leading to structure issue or even failure. This project may address the challenge of understanding how a frame structure behaves under assumed load and support condition by analyzing internal force such as shear force and bending moment and evaluating deflection. The project aims to ensure the structure can perform safely and effectively under expected load. Okay, so the objective of this project is to enhance student understanding of structure analysis through the evaluation of a real-time frame building structure. The analysis shall include load assessment, internal force, stresses, deflection, and the graphical representation of shear force, bending moment, and stress distribution. The main objective of this study on the structural analysis of a real frame building system are as follows, which is number 1, to analyze a real-world frame structure by identifying its geometry, support condition, and structure component using a clear symmetrical drawing. Number 2 is to calculate all relevant load acting on the structure, including dead load, lift load, and environment load, based on engineering principle and applicable code. Number 3 is to determine internal force, such as shear force, bending moment, and support reaction by using analytical method. Okay, number 4 is to compute bending and shear stress in structure member and illustrate their distribution through bending stress and shear stress diagram. Lastly, to evaluate structure deflection and present all findings through appropriate graphic representation, including SFD, BMD, and stress distribution diagram.
Hi, my name is Khairunisa Naziha binti Kamal. My metric number is CF240157. Today, I will talk about literature review. So, firstly, to design safe and efficient buildings, especially frame structure, we need to understand how material behave under different forces. This is where the field of mechanics of material become essential. So, in basic theory, engineers often simplify complete structure by assuming linear behavior and uniform material properties. One of the key theories used is the Euler-Bernoulli beam theory, which helps us calculate how beam bend under load. So, in real frame buildings, especially in earthquake zones, we must consider how the whole structure vibrates and responds dynamically. This depends on the stiffness, weight, and damping of the frame members as explained by Chopra. So, to deal with more complex building, we use computer simulation like the finite element method. Software like SAP 2000 help predict how frame will perform under various load using material properties like Young modulus and moment of inertia. So, studies show that when model are updated to reflect real life condition, the prediction become very accurate as shown by Chen, Lui and others. So, however, not all material behave in a simple or linear way. For example, when deformation become large or time-related effects like creep happen, traditional model are not enough. This is limitation highlighted by Hibler. So today, there's growing interest in eco-friendly materials like bamboo or natural fiber reinforced polymers. Research like Asher and Wasiuddin have adapted classical theories to test this new material, showing promising results for sustainable construction. So, in conclusion, mechanics of material give us the foundation to understand structural behavior. But to meet today's engineering challenges like earthquake, new material and sustainability, we must combine theory with modern simulation and real testing. So, that's all from me. We move to the next presenter. Thank you.
Hi, my name is Nur Izzah binti Abdullah. So for methodology, the first method is to use equilibrium of force equation. A body is in equilibrium if the algebraic sum of all these forces acting on the body is 0, and if the algebraic sum of moment of force about any fixed point is 0. So the second method is to use double integration method. Double integration method is a classical analytical technique used to calculate slope and deflection in beams under various loading conditions. It involves integrating bending moment equation twice respect to the beam length. So the last one is to use Macaulay's method. It allows using a single moment equation that applies along the entire beam rather than splitting the beam into sections. So Macaulay's method also reduces error when dealing with multiple loads.
My name is Nur Nagis Najwa, so I'm going to talk about our calculation for this project. So as you can see here, first of all, we find the total design load, which is we find the dead load, live load, and environmental load, and total them up to get the total design load. After that, we will find direction at each support and draw the free body diagram to get the shear force diagram and bending moment diagram. At the bending moment diagram, we will find the maximum moment for the beam. Then, when we get the maximum moment, we will use that to calculate our bending stress and the shear stress. After we get the bending stress and shear stress data, we will substitute in double integration method to get the max deflection for our beam. This is all our data from the calculation of our beam. In conclusion, this project focuses on analyzing the real beam structure that are located around UTHM and College Kediaman Luar Campus. By using the manual methods such as equilibrium equation and double integration method and Macaulay method, we can calculate the shear force, bending moment, bending stress, shear stress, and the max deflection for each beam. All the load estimation are according to a Eurocode standard, which include the realistic dead and live load. This analysis showed that every beam studied and performed within the safe limit for both strength and deflection. Through this project, we get a better understanding of how different support types, like simply supported, affect the beam behavior. It also helps us see how the structural dimension and loading condition influence the result. That's all from us. Thank you for listening. Goodbye.